So I was down here this evening playing around with the VFD again and having some fun, and I decided, I noticed that I was actually in low range, so I actually ran it all the way down to 50, and then I ran the frequency down to like 20 hertz, and it was amazing to see how slow that spindle would turn and still have torque. I was thinking, oh, that would probably come in handy, like maybe for tapping or something like that. I've got a tapping head. But then I decided, well, I want to see, let's max it out. You know, 4,200 RPM is the max speed, and I wanted to get a good feel for what it sounded like, how it ran at that speed. And well, this is the range selector, and this is neutral and this is high. And what's supposed to happen is this is supposed to move, and I even tried putting a wrench on and rotating the spindle while turning this to see if that's what was going on here. And this thing's frozen. I can't get it to move, which is disconcerting to say the least. You know, the funny thing is, I specifically remember testing that feature out on this mill before I bought it, so I know that was working. And the only thing I can think is that you know, when I had this sitting outside and we had all that condensation causing all of this flash rust and everything, that maybe something in here got rusted and seized. And unfortunately for me, I don't see an easy way to get in there and see what's going on. I'm going to try and shine a light down here, I guess. But I was wondering, maybe this oil cup is right in proximity, right over this area right here. I'm wondering whether or not, maybe if I put the oil cup in and put some oil in there, maybe it'll work free. I had taken the oil cup off quite a while ago when I was disassembling the mill to bring it down here, just so I wouldn't accidentally break it off. I should get a small wrench to do that right. Alright, let's put some oil in there. You can feel that the bottom of this section right here is pretty solid, so I'm not going to be able to see down in there into that section of the unit. If I can't end up getting this to work itself free on its own, then I'm afraid I'm going to have to take this apart. I really don't want to have to do that because of the weight involved. I'm going to have to take the motor off again, and then I'm going to have to unbolt this whole housing, and I'm not even sure if that's the right way to do it. Do not shift unless motor is running. That's this handle up here. Fill oil cup twice weekly. Spindle must be stopped when shifting back gear. Always disengage feed when not in use. That's the feed lever on the side here. I don't even know what that oil goes to. That might even just go to the bearings in here. And you're going to pull this out to release this pin to unlock it. I can see that I'm doing that. When I don't do it, I can see it locks into that. So it's not that I'm not unlocking it, it's that that shaft doesn't want to turn. I don't know how much force I could put on it to try and break it free before I run into a problem where I actually break something. I'm running it at a very, very, very slow speed so that I can mimic the act of putting my handle on the drawbar, but I'm going to shut it off. Do with that handle. Alright, here's my thinking. I'm thinking I don't want to just like try tapping on this handle with a hammer. I did that with this light non-marring mallet. I don't want to bang on that too hard because I run the risk of breaking the handle. But I do want to try and put a little bit more rotational force on this shaft to see if I can get that to break free. So what I'm going to do is I'm going to put a pipe wrench on here. That way I'm not exerting all that force out here on the little thin part of the handle. But I think I want to wrap that so I don't mar it all up with the... Now I want to wrap it, but then at the same time I want to be able to see if it's moving at all. That ain't happening. No, that's quite a bit of force I'm putting on there. I'm going to snap this shaft if I try any harder. I think what I might just do is I might inquire online and go on the Practical Machinist website, go on one of the forums there and start a thread. I already looked and I searched the threads and I couldn't find anybody inquiring about this particular problem. And I don't think Keith Rucker would be able to help me out because I get a feeling he never probably had a problem with his. Probably just worked from the get-go. I mean, like this was working. The max RPM on this thing is 525 in low range. If I use the VFD and overrun the motor, run the motor up a little bit more, I could probably get up to around 650 RPM. The question is, do I really need those higher speeds? Well, I don't know. You know, the other thing too is I've never taken this end mill is the one that was in here when I bought the machine with the collet that's in there. I've never taken them out. And I stumbled across a couple of the threads in the forums, people talking about what they described as the dreaded stuck collet problem on these. When this mill runs, the top of the drawbar there almost looks like it's bent the way it runs. But then I noticed tonight, I watched Keith Rucker's video again when he's demonstrating his mill, and I watched him easily shift this out to neutral, and then he had to rotate it a little bit to go into high range, but the point was it came right out into neutral, no problem. But anyways, while I was watching his video, I noticed his bar was wobbling too. But then later in the video he said it was making a lot of noise because he said his drawbar wasn't tight because he didn't have a collet in there, I don't think, in that video. So I don't know. So why don't I do this? Why don't I try and take that out? So the procedure there is essentially you gotta pull this handle to keep this from turning. And then unscrew this. Like that. Now, you unscrew it just like a little over a turn. Don't unscrew it any further than that, because the next step is to whack it. Just enough to pop the collet free. Now, while holding the collet, I can finish unscrewing it. Well, I don't have a stuck collet problem. Now you can hear it. That would really rattle like heck. Alright, so I don't have that problem. That's good. Well, I posted my inquiry on the Practical Machinist website about my problem here with the Wells shifter and the range shifter, and got quite a few views and no responses, which tells me that nobody has an idea of what I should do next. So I just took out all the screws that appear to hold this top casting right here on. I'm hoping that this whole speed change lever assembly and assembly will be able to come out as a unit, and maybe let me take a peek down inside there and see if there's anything I can see. That's really tight on there, so I just use this old chisel to get in there and pry it open. Problem is, I don't even know whether or not I'm just supposed to be able to remove that without taking this lever off first. I don't know whether or not it's just stuck on there, or whether or not I'm doing this completely wrong. I see some surface rust in there on those components, and I'm beginning to think that that's where part of my problem lies. Oh, that looks like that whole sheave pulley assembly pulls out of the top of the spindle. So I'm not going to be able to do anything until I take this belt off. Alright, I have to unbolt the motor and slide it over to take the slack off so I can get the belt off. Battery's dying again. Alright, so I recharged my battery, and talking about how this all came out as a whole unit, and basically the mistake I made when I went to take this out was I should have placed the speed selector, should have turned it on while it was running, turned the speed selector over to the highest speed, and what that would have done for me is that would have opened up this sheave and made the effective diameter of this pulley smaller, which would have made it easier for me to get the belt off. And then I would have wanted to take the belt off before I actually unbolted this. But I was able to get it apart, so no harm, no foul. Now, when I took this apart, this bearing, I see that this bearing on the bottom here, and bearing's noisy, so I wouldn't mind changing that bearing to a new bearing, a quiet running sealed bearing. That might actually quiet this mill down quite a bit. Certainly worth looking into. Well, I just brought this over to the bench to take a look at it, and cleaned up this bearing, and there's a clearly a bearing number right on here, 6212Z. So I know that's going to be a good bearing number. You can tell just by the number 6212Z. This particular bearing that's in here says it was made in Poland, so that could easily be an SK. SKF, I mean. That's it's a little YY on it. I think I've seen some SKF bearings that came out of Poland. But anyways, I don't know if you can hear that, but when it spins down, there's a little bearing noise there. So I'd like to replace that if that bearing's not going to be extremely expensive. I think the fact that it begins with a number 6, I think that means that's going to be like a 6000 series bearing, so it's probably going to be a little bit more expensive. But the other problem I see is that it looks like the only way that bearing's coming off is this way, and it can't get past this part. So this part right here has to come off of that shaft in the middle there. And the only other thing I noticed, since I'm here looking at it right now, is you notice right here, black Sharpie is written 11-80. So I'm thinking that's a date, November 1980. So I'm wondering if that's the date of manufacture of the mill. The other possibility is that it's a date of a rebuild that was done on the mill, but I'm thinking that might be the original manufacture date. I think that might be the original bearing. So I'll write that number down and I'll look it up later on. Right now I want to get back to what's going on with the head. I think what I'll do now is get this motor off the top so I can tilt the head back over. Alright, I'm going to tighten up two of these bolts, two of these nuts, locking nuts, so that the head is not keeping all its weight on that worm here. Alright, so now I can see right in there. Just wish this light was behind me. Part number right on this belt. Speed Selector Inc. 8007. It's not cracked. It actually doesn't look like it's in that bad a shape. There's another part number here stamped into it. 1922 V403 and then a space 85. I wonder if that 85 means this is a 1985 belt. Maybe the mill was built in 1980 and maybe they changed and put a new belt in 85. Of course, if this belt was made in 85, that doesn't necessarily mean it was put in 85. It could have been sitting in a warehouse. Now I'll just show you what I'm looking at down in here. It's not what I was hoping. So the belt, this small belt right here is what drives the feed, and you can see now it's not engaging anything, so obviously this small belt is what goes around that what I thought was like a sector gear. So that's not what actually locks this to the spindle. This spindle's got a spline shaft to it right here. So I guess somewhere down in that hole there are splines, and that belt rides on this right here. Hey, wait a second. You know, when you turn this right here, that in there is turning. So maybe this isn't the feed. Maybe this belt is actually a main drive belt, and maybe this is like the back gear. Maybe this whole back gear switching is happening right up in here. And I'm looking down in there and I'm seeing some rust. Alright, so I figured this thing out, and the way it works, this small belt here, which because of its small size, made me think it only had to do with the feed drive for the downward feed for the quill. Turns out no, this is actually this gear, this belt, and the parts I took off, they're all right here. This is all your back gear mechanism, the way this works. So what happens is right now it's stuck in the low range. So what happens, the sheave that I took out has that sectored cog gear on it. That cog gear is affixed to the main shaft that the sheave is on. So that cog gear is going to spin at whatever speed this big sheave pulley that I took out of here is spinning at. So that's locked to that, always. So then what happens is, right now, because it's in low range, when I have this installed, that cog gear on the bottom has a couple of notches that these dogs right here are supposed to engage when it's in high. But right now this is down so that it's not engaging those notches. So what happens is that allows the cog gear to drive this belt, which drives this pulley, which there's a shaft underneath here that must go to a gear that we can't see underneath here, that then in turn engages the this collar that is splined to the shaft here. So that's why when I turn this, you can see it's turning the whole deal there, right? So how does direct drive work? Well, direct drive would work when this handle is moved up to the middle notch. That would be neutral. And what would have to happen there is this part right here would have to come up high enough to disengage what's underneath here that we can't see, but not high enough to engage the notches on the bottom of that cog gear. So what happens there is that's neutral. And then if we move the lever all the way up to high, that's when this right here moves up high enough so that it does in fact engage or lock into the notches on the bottom of the sector gear. And at that point what happens is the sheave and sector gear are directly driving the spindle right here by engaging these little dogs right here. All right, so this lever is supposed to make this ring right here go up and down on this spline shaft. That's how this works. So the reason why it's not working is because you see all this rust? That has gotten into where we don't want it. So what I want to try and do is spray some penetrating lubricant in there to free that up. But I don't want to get any of that stuff on this belt. So right now, the way it looks to me is I think if I take a series of hex cap screws out around this perimeter, I think I'll be able to actually remove this whole head unit right here. And the belt will slide up off. And that'll give me really good access to that. The only thing I'm not sure about is whether or not this pulley, the shaft underneath here, will just slide up and off, but we'll find out.